Hey everyone, this is lesson 11.4. We are on page 319 in your textbook. This lesson is about writing inequalities. The essential question says, how can you use inequalities to represent real-world constraints or conditions? Our explore activity is using inequalities to describe quantities. You can use inequality symbols with variables to describe quantities that can have many values. So up until now, we've been talking about a variable, let's say x, and we've been finding out what that equals. Maybe our answer is x equals 2 or x equals 47, whatever. It equals one thing. But now we're going to be learning about inequalities, and inequalities can be used to describe quantities that can have many values. Not just x equals 2, x can equal many different things. So to know this, we have to know what inequalities are. An inequality are these symbols right here that you see in this column. These symbols have meaning. So let's take a look at all of the meanings that we have here. So the first one, this symbol means less than. And if you were doing a word problem, you might see the words fewer than or below. The temperature is below 47 degrees. That would be less than. This next symbol right here means greater than. And in a word problem, they might say she has more than he does, or the temperature is above. That would be where you would use a greater than symbol. The next symbol is less than or equal to. You'll notice on an equal sign, we have two parallel lines like that. Well, they just take one of those parallel lines off and they put a less than symbol on the top, and that means less than or equal to. In a word problem, you might see the words at most or no more than. He has no more than $15. That would be a less than or equal to. And the last symbol is a greater than or equal to symbol. And in a word problem, you might see the words at least or no less than. So he has at least $15. So those are our inequality symbols that we're going to be using for this lesson. So let's scroll down. There's our little alligator. On part A, it says, the lowest temperature ever recorded in Florida was -2 degrees Fahrenheit. Graph this temperature on the number line. So I'm going to come over to the number line. I'm going to find -2, and I'm going to graph it. Part B says, the temperatures 0 degrees Fahrenheit, 3 degrees Fahrenheit, 6 degrees Fahrenheit, 5 degrees Fahrenheit, and -1 degree Fahrenheit have also been recorded in Florida. Graph these temperatures on the number line. So I'm going to change colors. I'm going to come up here and show you. Here's 0, 3 degrees, 6 degrees, 5 degrees, and -1 degrees. Okay, now we're on part C. How do the temperatures in B, these temperatures I just graphed, compare to -2? How can you see this relationship on the number line? Well, if we look at all these red dots, all of the temperatures that I just recorded, we can see that they're all greater than -2, right? -2 is the lowest number to the left, so that means everything to the right has to be greater than -2. And they're all located, if number 2 is here, -2, then they're all located to the right. So a good answer for C, I can say they are all greater than -2. And all of the temperatures are located to the right of -2. All right. Oop. And I move down where it needs to be. Part D. How many other numbers have the same relationship to -2 as the temperatures in B? Give some examples. So it's asking us how many other numbers share this, that they're all greater than -2, They're all temperatures located to the right. Well, just looking at our graph, I can see quite a few numbers that would share that relationship, like 1, 2, 4, 7, 8. I know if I continue my number line, 9 and 10 and 100 and 1,000 and forever and ever, right? Numbers are infinite. I can always add another number. So we know, how are they related? Well, there's infinitely many numbers that would work. And we can further explain ourselves by saying any number greater than -2 would work. And we could even go on and say an example would be 1 or 7 or 100. I think that's a good answer. Okay. Part E. Suppose you could graph all of the possible answers to D on a number line. What would that look like? What would that graph look like? Well, we know when we have a number line, if we're going to graph all the numbers on the right of -2, that's going to be a ray like this. It's going to have a start at -2, and it's going to go on forever. And that's what that arrow is going to tell us, that it's going to go on forever and ever. But it's not going to include -2 because -2 isn't bigger than -2, right? So we're going to put our answer. We're going to say, what would it look like? It would look like a ray extending to the right of -2, but not including -2. Because again, it's saying which are greater than -2, and -2 isn't greater than itself. It is itself. Okay, part F says, let X represent all the possible answers to D. Complete this inequality. Well, if this is the case, and X has to be all of these answers, everything to the right, then we know we can use an inequality to say that X is going to be greater than -2. Good job. You guys are done with page 319.